Hi guys, how are you all? Farah here. The others also are joining. Can you guys turn on your videos? So yeah, guys, how's the preparation going now? Vishwesh?
Going good, sir.
Okay. Any update? Any exams being conducted in school? Like pre-boards or something? It's over.
All the over, sir.
Okay. Shinjini, all going good?
Yes, sir.
Okay, nice. So guys, last week, in the session we had last week, where we discussed the most expected questions from light and electricity. Here we are going to discuss the most important questions from electricity and magnetism part. So light and human, I will discuss. Electricity and magnetism we are going to discuss today. So I hope you guys have attended the revision classes that we had earlier from these two chapters. You have, guys? So here we are going to discuss, like, of course, there can be many important questions, particularly the definitions, derivations. Those are most important. Theoretical questions can be asked from there. But here we are going to discuss high weightage questions, either the questions which probably you have not seen earlier, or important derivations which are going to have high weightage. So let us quickly begin with it. Quickly, we are going to discuss what all things you can do in least amount of time to get maximum marks in these two chapters particularly. I'm requesting everybody to keep their cameras on. Farah, Neeraj, Om, Ashita, Alan. Okay, so in electricity, first of all, the chapter starts with the concept of charge. So definition of charge, SI unit of charge, this you guys should know. Definition of current, SI unit of current, you should know. And there were a couple of formulae also related to resistance and all. But the very first thing that I want to discuss with you guys, which I believe is kind of the most important, one of the most important questions that is there in the entire grade 10th physics, which will most probably come, is the derivation of the formula of series and parallel resistance. So that is what we are going to discuss first. Quickly, we are going to revise what it was. Combination of resistors. First of all, let's take series. First, we're taking series combination. So how do we derive the formula for equivalent resistance? First of all, we take the three resistors in series, R1, R2, R3. So the question that we are discussing is find the relation or derive the relation. Derive relation for equivalent resistance for resistors connected in series. For resistors connected in series. And if it is asked, it should be a 3-mark question. So here we are going to write all the steps in detail. First of all, we are going to assume the three resistors in series. We are going to take them and we will connect it to a battery of a voltage V, and we will take some current I coming through it. Then we are going to mention, important point over here is that current through resistors connected in series. Through resistors.
Good evening, sir. So sorry to no, like, have you started just now?
Yeah, we have started just now. This is the very first thing that we are discussing.
Okay, sir.
Yeah, for 1 mark, no, it's going to be a proper derivation. A number of steps will be included in this. So current through resistors connected in series is same. Then guys, what do? We are going to write the potential difference over each of these. V1 over this, V2 over this, V3 over this. And we are going to write that potential in words. We are going to write this potential difference over the first resistor. V1. What will the value of it be? Potential difference over the first resistor. The current through it I, which is common for all, into its resistance. So I into R1. But make it a habit in all derivations, whatever you're doing, even in calculations, wherever you use a formula, you have to write it. Which formula or what equation are we using over here? What should I write in bracket? Why is V1 equal to IR1?
Ohm's law.
Yeah, from the Ohm's law. It's important to write this. Then you don't need to write the statement again and again. Potential difference over second resistor. Just
Ohm-
write.
Ohm's equation.
No, Ohm's law only I'm going to write. There's nothing called Ohm's equation as such. Like that's not the official name, at least. Maybe people are using it, but officially it's not the name. So similarly, you're going to say V2 is IR2 and V3 is IR3. And V3 is IR3. Then you're going to draw another circuit. This is also important. Draw another circuit with same voltage and same current I. Voltage is going to be same, current is going to be same. R equivalent you're going to write over here. And then you're going to say for the equivalent circuit, for equivalent circuit, you would say total potential difference V is current into total resistance R equivalent. So give these numbers 1, 2, 3, and this fourth. Then guys, what is the next step that we're going to do? Can somebody answer?
So we can write that.
V is equals to V1 plus V2 plus V3.
Okay. So if I want to write V equals to V1 plus V2 plus V3, I should give the reason also. What would you write as the reason? Since what? What's the reason that V1 is V2 plus V3? Yeah.
The total voltage, like
What about it?
combined voltage.
What should I write? Combined voltage over here. Combined voltage. That's an incomplete statement. Yeah, Jasim, exactly. Perfect. Yeah, can anybody else try? What should it be?
So equivalent, like potential difference.
Like what should I write over here? Equivalent potential difference, and then write V equals to V1 plus V2 plus V3. There's nothing called equivalent potential difference. What will that statement be, guys? You're going to write since potential difference provided by the battery splits or divides over the 3, that means if you add up all those 3, you would get the equivalent one. So V equals to V1 total one. So V equals to V1 plus V2 plus V3. Then you're going to write substituting from equation 1, 2, 3, 4. This will give you IR equivalent is IR1 plus IR2 plus IR3, and then we get the answer. So similarly, guys, take it as a homework after the class. Do derive the equation for the relation for parallel resistors also. We should have a very good practice over it. Don't take it lightly that you have done it for series. Parallel, so you'll be able to manage. No, you might just get confused at that time. At least in rough, try to solve this and get that relation. This is for series. For parallel, you guys know 1 upon R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. This is for parallel combination. What could the other question be? First question is this derivation based question where we have to write all these steps for 3 marks. So Avida, this definitely cannot be a 1 mark question, right? We can use 2 resistors. So Jasim asking, can we use 2 resistors? Ideally, at least use 3 resistors. 2 is a little too less. Let's try to use at least 3 so that we can see a whole pattern. Yeah, in fact, could be a 5 mark question also the way we are writing it. So anyways, moving to the next question. Like most importantly, the questions which I wanted to discuss over here are from PAR formula. Everybody remembers the formula for PAR, right? One question will be,
Yes.
a heater is connected in parallel to the bulb of power 60 watts while being connected to a power source. Okay, so the question is, if the resistance of the heater is increased, the bulb glows brighter or dimmer? What will the answer be? And of course, they can mention why also after this. So what do you guys think? There's a heater connected in parallel to a bulb of power 60 watts, and it is connected to a power source, like a battery or something. So if resistance of the heater is increased, what difference will come in the bulb? Will it glow brighter or dimmer or what?
Sir, the resistance of bulb is constant.
Yeah, Ram?
The resistance of bulb is constant, right?
Yeah. No, Yasim, that's wrong. In fact, this question could be an MCQ type of question also. Just remove the word why. No, Sai, not correct. No, Aram. Okay, let's discuss it. First of all, guys, we're going to draw the circuit for it, right? Do you have the circuit in your mind? No, Avida. See, what is the circuit? There is a heater over here. In parallel with it is a bulb. And these two in parallel are connected with a power source, a battery of voltage V, we can imagine, right? Now they are saying this is the resistance of heater R1, this is the bulb's resistance R2. What is the formula for power over the bulb in this case? Power delivered to bulb. What formula should I write for it?
So I square R2 times T.
No, not times T. T gives me the energy. I have to find just power. So there are three formulas that we can use. I square R, V square by R, and V into I. Which one makes most sense to use over here? No. Abhida, correct.
V square by R2.
V square.
V square by R. Because guys, see, here directly voltage is given. Why would you not use it? What is the potential difference over this bulb? V. So V square divided by R2. Now tell me if R1 is increased. If R1 is increased, this expression will increase, decrease, or nothing will happen. It remains the same. Exactly. Correct, Ashita. Just see, it depends upon the original voltage V and the resistance of the bulb. Whatever you do to the heater, why should it matter? Maybe, let me give an example. If, for example, this bulb was 20 watts and this voltage is 100 volt, and this resistance is, this heater is also 20 ohms. So how much current will they draw? Can you imagine? 100 volt over 20 ohm. It will draw 5 ampere and it will draw 5 ampere. If I later make this from 20 to 40, What would happen in that case? Actually, just this heater will have 2.5, but this will still draw 5 only. Bulb will not change. Because why? Because they're connected in parallel. Getting this, guys? In fact, that is why in domestic circuits, appliances are connected in parallel. So that if in future, my heater stops working, my bulb will remain unaffected. So second part of the question will be,
Sir, because like the appliances created in parallel, like draw their current independently of the other.
exactly, yes. So now the question is, what will happen if they were connected in series? Arey, explosion. Actually, it will happen. It will happen. If you double the resistance, not in that case, if you increase it, but if you decrease it, it might happen. But anyways, let's not go into that. What will happen if they were connected in series and now the resistance of heater is increased? Not in this exam alone. Yeah, Ashita, correct. Correct, Aram. Correct, Apratim. Yeah, R of heater is increased. Oh, yes.
So like are these variable based questions like asked very often in boards?
One question, like, I don't know how you would put it very often or not. It's one question. Yeah, guys. No, Abhida, not right. See, again, we're going to draw the circuit for it. They are connected in series. Yeah, Jasim, correct. Heater. Okay, Ram. Of Ohm's law. Guys, this is how it's connected. Voltage V. Resistance of heater, let's call is R1. And resistance of the bulb is, let's say, R2. So what are you going to write as the power dissipated on the bulb? What formula are you going to use this time? V square by R or I square R? Okay, Jasim, fine. Yeah, correct. We are going to use I square R. Can I not use V square by R? V square by R2. No, the problem is this potential difference V is not present over the bulb. It will split over these V1, V2. We don't know how much. So let's not even go into that. Safe side, use the formula I square R. The current in this circuit, let's assume I, the formula is I square R2. Right, guys? Now tell me, if R1 is increased, will any of these quantities change, current or R2? If the voltage, if the resistance R1 is increased, will the current in the branch change? If I increase the resistance of the heater, will the current in the circuit increase, decrease, or remain the same? What will happen? It will decrease, isn't it so? That's the whole point of calling it resistance, right? That if you increase the resistance, current flow will be less. The current is going to drop. So what is going to happen to the bulb? The power is going to increase or decrease? current is decreasing, so it's going to decrease. That means bulb glows dimmer. That is the reason we do not want to connect electrical appliances mostly in series. That if some change happens in the first one, in second one also changes will happen. Everybody clear about this? So depending upon the situation, we use the formula V square by R and I square R. If it is in parallel, we prefer using V square by R. If it is in series, we use the formula I square R. Now the biggest confusion. They ask a common question. Why heater or the coil of the heater, I should mention the coil of the heater, is made of nichrome wire. What would you write as the answer for this? Yaniraj, correct. No, this is not the reason, Apratam. Yeah, Veda, correct. Yeah, everybody knows this, right? It has high resistance, high resistivity. Okay, fine. So I was telling you the biggest confusion over here. If you guys already have by hearted, it's perfect. But you know the confusion that people have, P equals to V square by R and I square by I square R. So to increase the power, what should we do? Should we decrease the resistance or increase the resistance? Because according to this formula, it's inversely proportional. According to this formula, it's directly proportional. So which formula should we use? Now, kind of just by heart it, we use the formula I square R. Power is proportional to resistance. There is a reason. The reason lies in how you make a heater. Actually, you connect something in series with it, but you don't need to get into it. Remember, power is proportional to R in this question. That means for more power, for more heating, you need a wire of, since it has high resistivity and a high melting point, so that even on getting heated up a lot, it does not melt easily. So these are the two reasons for which it could be a 1 mark question, 2 mark question, depends, but mostly it will be 1 mark question only in my opinion. High resistivity, high melting point. Then another question that they can ask. A heating coil, let me give you this question. Is rated
Sir,
100 watt, 200, just a
power.
second.
Sorry.
Let me just give the question, then I'll take up your question. If it is cut into 2 equal parts, and connected in parallel, what is the energy liberated per second through them? To the combination. Yeah, Ram, first of all, your question.
Sir, like power is inversely proportional to resistance, right?
That's what I'm mentioning. Actually, if you depends which formula you're using. V square by R. Shinjini, you also asking the same thing. According to this formula, it seems it's inversely proportional. According to this formula, it seems it's directly proportional. So which one to use? So what I have told you is, The reason is not given in NCERT at grade 10th level. Actually, the reason is there is something which is always connected in series with the heater to control the current. But don't think about that thing. Just by heart it that when we talk about the property of heater's coil, what the material should be. So we do not use V square by R, we use I square R formula. So according to this, is proportional to it directly. Just by heart it. Fine, Chanjini?
So like it depends on the situation we are using, right?
Yes, actually it depends on the situation. The situation should be like this. In parallel, V square by R. In series, I square R. But if it's not mentioned, it's I square R.
Okay, sir.
Yes, Vishwesh, it would be in that case. Okay, Avida, I'll check. Correct, Avida. Right. No, Aram, not right. Yeah, Pratim, correct. Acha, Abida, I did not notice. What is the energy generated per second? Oh, your answer is right. Apratim, your unit is wrong. Can you check? What should the unit be? Right. So Farah, what have you done till now? Yeah, Jasim, correct. Oh, sorry, Jasim, it's wrong. The unit is wrong. Value is right. Yeah, Farah either. Yeah, Vishwesh, correct. Perfect. Yeah, I'm right. Okay, Jasim, correct. Yeah, you guys are getting it. Great, great, great. See, guys. Here, what is the question? Here they're saying there's a heating coil which will give out 100 watt of power if it is connected to ohm, correct? But units are wrong. When it is connected to 200 volt. That is the meaning of 100 watt, 200 volt. That if it is connected to 200 volt, it will give out 100 watt of power. Now, if it is, since it is broken, first of all, I'm so sorry. First of all, we should find the resistance of this resistor, resistance of the heating coil. What will it be? How would we find the resistance if power and voltage is given? We remember the formula. Power is V square by R. So we can say R is V square by P. Correct. So that is 200 square divided by 100, which comes out to be what? I guess 400 ohms. Is this right, guys? Okay, perfect. So now what we have is, guys, this heating coil is broken into two parts and then they're connected in parallel. Let me draw it a little more properly. Yeah. So what is going to be the resistance of each part? Resistance of each half. Let's call it small r. Can we say it's going to be half of it? Length is half, resistance is half. So it's going to be 200 ohms. Everybody clear with this? Because resistance is proportional to length. If you cut it into half, half the length will have 200, other half of the length will have 200. So R and R in parallel with how much voltage? Same battery, 200 volt. So what is going to be the equivalent resistance of these two? Yeah, it's going to be R by 2, which will be 100 ohms. The situation that we have over here is, ohm in the question it was given 200 volt. That is why we are taking it. In the question it says 100 watt when 200 volt is there. So guys, finally we will have, if we have got this equivalent resistance, it's 100 and we have connected it to 200 volt source. Can you imagine that power dissipated is going to be V square by R equivalent, which is 200 square divided by 100, which is 400 watt. So is this the final answer? Actually, I was mentioned to some of you, units were wrong because power is not being asked. Energy liberated per second is being asked. Now you would say energy per second is power only. Kind of true, but they are not asking what is the rate at which energy is getting dissipated. They're asking how much energy is there in 1 second. So the answer is 400 joule is dissipated in 1 second. The question was what is the energy dissipated? That is 400 joules in 1 second. Although it is same as claiming it's 400 watt of power. Everybody got this point? Okay, Aram, I'll discuss it at the end. Fine. So I hope all is good. Let's proceed to the next thing then. We are moving to magnetism. And the most important question of magnetism is, what is magnetic field? Sorry, what are magnetic field lines? In fact, let me give all the questions. What is magnetic field? What are magnetic field lines? State the properties of magnetic field lines. So what is magnetic field, guys? How to define magnetic field? Correct, Justin. Perfect definition. It is, guys, basically the region around a magnet. Region around a magnet where its effects or influence can be experienced. That is the standard definition as per the boards. Then the next question is, what is magnetic field line? How to define this, guys? You cannot use the word field in the definition of field home. So ignore the word, like try to avoid the word field over here. Jasim says line along which North Pole tends to move towards the north. Okay. Representation of magnetic field on a stream. Yes, Aram. Yeah. Magnetic lines which show direction relative strength of the magnetic. Yes, correct. Like you can say in short, magnetic field. Yeah. Yeah, correct. Force in place of effect. Actually, that is more appropriate, but they are writing in the like according to the CBSE, it's just effects is sufficient. Those drawn in region where magnetic fields. No, Ritik, not correct. Yeah, I'm correct. So guys, basically magnetic field lines, like let me write in short, magnetic field lines are representations of magnetic field at a given point. Then you can mention it indicates the magnitude and direction of magnetic field at a given point. Although your definitions also are right, I do not disagree with them. Direction of magnetic field at a given point. Now this Ohm will come in the 5 properties that we have. I have just mentioned right now, guys, that it can indicate the magnitude and direction. Now, how it does it? That comes under its 5 properties. So we have discussed this earlier also. I'm just quickly giving you a hint on what all the points were. First point was what? In the right order. What was the very first point? Emerge from north. In a bar magnet, magnetic field lines emerge from north. I'm just writing in short. You're going to write the full statement. Emerge from north and go into south. Pole of the bar magnet. Second one was it forms complete loop. Sorry, forms closed loops. Yes, closed loops. Third point was finding the magnitude of this field. Magnitude is basically what? Sorry, how do we find the magnitude? By the density of field lines.
So closed loops is same as concentric circles, right?
No, closed loops can be like, it's not necessarily they are circles. This is also a closed loop, a square. Like if current is going like this, if you draw a square loop, this is also a closed loop. So it's not necessarily circle only every time. Density of field lines gives us the magnitude. How do we find the direction?
So can we mention that like a circular closed loop?
No, because it can be of other shapes also. If, for example, in solenoid, what was the direct shape of magnetic field? Straight lines. In solenoid, it was straight line magnetic field. So should not mention that it is circular only. It was also a closed loop. It just went to infinity and came back. But this is not a circle. Yeah,
Okay.
Yeah, so that how do we get the direction? By drawing the tangent at the point. Tangent at the draw a tangent to the magnetic field line at a given point, it will give you the direction of the magnetic field. And fifth was they do not intersect. So we have discussed this earlier also, why they do not intersect. Because if they intersect, it would have meant that it has 2 directions. Magnetic field has 2 directions at that point, which is not possible. So these were the important points that I wanted to discuss from here. If you have any questions, please let me know, guys. Yeah, it is preferred Ohm. Like depends upon the examiner also who is checking it. So let's not take risk. Let us always write in the right order. Because there's a logic behind this order also. First, you're telling in the first 2 points, you tell what magnetic field looks like. In third and fourth point, you tell what you can deduce from it. You can find magnitude, you can find direction. And once you understand all this, only after understanding this, you would know that they do not intersect. Because in your explanation of do not intersect, you are saying that if they intersect, tangent will be 2 points. So imagine if you do not know what they look like, if you do not know what tangent gives, how can you reason the fifth point? So that is why they should be in the right order. Correct, Ritik. Perfect. Now, guys, another important question, maybe directly, maybe indirectly, it would be, Shinjini, we will discuss that. That will be like at the end of this chapter, we will discuss it in around next 10 minutes. To draw the field lines, question will be to draw the field lines due to first straight current carrying wire, second will be okay, let me just write it over here itself. Straight current carrying wire. Second will be due to a circular coil. And third is going to be, I don't know, if this is asked, we should be prepared for a solenoid. So for a straight current carrying, what does it look like? Which rule do we use, guys, to find the current due to magnetic field due to straight current carrying wire? Which rule is it called? Yeah, Maxwell's right hand thumb rule. Maxwell's right hand thumb rule. So point your thumb in the upper direction. Magnetic field lines are going to curl around it like this. Is this fine, the figure that I have drawn? Or something is wrong about it? No, not the board. Something else. Think about the density of field lines. Shouldn't the magnetic field get weaker as we go farther? So shouldn't the magnetic field lines get more and more separated with time? Like this. Density is reducing outwards. Density of field lines is reducing outwards. That means magnetic field is becoming weaker as we go farther. Next question could be to find the draw the magnetic field due to circular coil. So you're going to draw the circular coil like this. There are two possibilities, two ways in which you can draw it. Both are given in NCERT. You can follow any of them. You can draw it like this also. Well, like this. This is the current that we are drawing. So what would the magnetic field lines look like? Imagine the same thing. For every point, imagine curling your thumb around it. So it's going to curl around it like this. I mean, point a thumb, curl your fingers around it. So it's going to be like this. Or in this case, you can imagine it's going to be like this. But due to a solenoid, what does the magnetic field lines look like? Yeah, imagine, like, just remember, it is like many coils placed side by side. So one is like this, current is going down in this. So what will the magnetic field line look like? Leftward or rightward, guys, in this case? If you want, I can draw it a little more properly so that you can clearly see. Like this. And the current is going like this. So would there be leftward magnetic field or rightward magnetic field? No, that is fine because the question would be very direct. We don't need to draw all that every time. Question will be to draw the magnetic field lines into solenoid. So we can draw this. Yeah, Bida, correct. So guys, treat each of these as a single ring. It's like a ring where current is downward. So imagine curling your fingers around it. So if your thumb is downward, can you imagine? Magnetic field lines are going to go around it like this. So inside it, it will be going rightward. That means overall, there will be rightward magnetic field. This is what the magnetic field will look like. Let me know if you want me to repeat this, I can. No problem at all. After this was Fleming's left-hand rule. From that also questions can be asked.
So,
For example, yeah, tell me.
so in the solenoid, like the strongest magnetic fields, like produced at like the center, right? Like any point in the solenoid,
Sorry, I
right?
don't understand.
So like the strongest magnetic fields like are produced like within the solenoid, right?
Yeah, inside it, yes.
And in a bar magnet, like they're like nearer to the poles, right?
Actually, it's not true. A solenoid and a bar magnet are the same thing. Like if there's a solenoid like this and there's a bar magnet like this, then both have the exact same magnetic field. It is the same thing. It's just that they mentioned that in bar magnet it's largest at the pole because you cannot go inside the bar magnet. But in a solenoid you can, right? Inside you can go, you can experience larger magnetic field. So it's about like more like application. Where would you use like the magnetic field? Magnetic field's largest value in a solenoid inside it. But can you go inside a bar magnet? No, you cannot. So there you use it at the poles.
Okay.
Conceptually it's same. It's just that application wise for bar magnet comes out to be at poles because that is the one you can only claim. Jasim, it is actually true only for infinite solenoid, but I think that is not there in your grade 10th syllabus. But yeah, in only in infinite solenoid it's same everywhere. Otherwise it varies. At the center it will be maximum. Okay. Fine, guys. Next thing actually which I should be discussing is making electromagnet. How will you increase the strength of an electromagnet? So there will be 2-3 points in this. So yeah, you are telling me first one is Aram says increasing the current. What is electromagnet? Electromagnet is nothing but this solenoid only. This solenoid with some current passing creates a magnetic field. This is the electromagnet solenoid. So first suggestion that he gives is we should increase the current in this. Yeah, if you increase the current, becomes a stronger magnet. What else can we do? Number of loops or number of turns. Yes, not exactly that, but we should say we should increase the number of turns per unit length. Like the thing is, would now increasing the number of turns help? Imagine this is one solenoid. If I increase the number of turns like this, is it a stronger electromagnet? No. Number of turns should increase, although like it has, for example, it has 8 turns. This has 16 turns. But still it is weak because you see it's spread out. So important is not to increase the number of turns. It should be increasing the number of turns in a given length. So per unit length, it should become 16. So it's not about number of turns, increasing number of turns per unit length. So please mention that also in your answer. And the third, what is the third method? Abida, you're right. Guys, what is the third method of increasing the strength of electromagnet? Material of what? Electromagnet is made up of copper wire only, Ritik. Yeah, correct, Jasim. So you do not change the material of this. So material of what, Ritik, it is? Material of the wire, the coil? No. Actually, instead of using this solenoid plane, you can insert a soft iron core inside it. Insert a soft iron core. Insert a soft iron core. So like something called magnetism, like magnetization happens, but that you will study in later grades in 12th grade, magnetization. But basically what happens is if your green magnet solenoid was creating 2 Tesla magnetic field. So this induction inside this is going to create 3 more. So total will become 5. So something like that happens. You don't need to know that. If you insert soft iron core, the magnetism or the strength of magnetic field increases. After this, an important question that they can ask you to draw. Draw a diagram of a domestic circuit. What do they mean? What do you have to draw in this?
So like a live wire with a fuse on it and like a neutral wire, that.
Correct. Exactly. So guys, there will be 2-3 elements in this. Yeah, the last page is NCERT. That figure you will have to draw. So let me mention all the elements that were there. It would be a quick recap and important things that we have to note. First of all, it goes into an electricity board's fuse. So the electricity which is coming from the powerhouse from outside, first it will go into the fuse. So 2 wires are there, you know about it. First is called the live wire, which is what in color? What is the color of the live wire, guys?
The red or brown.
So let's draw this. That is going to be red in color. This is the live wire. And what's the color of the neutral wire? I cannot draw this over here. It's black, but if I draw black, you will not be able to see. So I'm drawing it in white, but please notice it's black. It's the neutral wire. So live wire is like the positive terminal and neutral wire is the negative terminal. Now, in which one of them fuse is connected? Fuse is connected to the live wire or neutral wire?
So live.
Yeah, so this also you need to remember. The fuse is actually connected. See this whole box is fuse. Technically, it's connected over here. This is the wire made up of tungsten. Tungsten wire, the fuse wire. What is its property? This could also be a question.
So high resistivity.
Yeah, it has high resistivity.
And like generates a lot of heat.
Yeah, it should heat up. But unlike heater, it should have a low melting point. So that at least it melts up when it's sufficiently heated. Otherwise, what's the point of connecting fuse if it doesn't break? So these two go into the next element, which is the electricity meter. The meter that you have in your homes, which measures the amount of electricity consumed. Electricity meter. Then from this electric meter, it goes into the distribution board. Basically, inside the walls of your home, there is this distribution board from which it's like not exactly in the wall, could be sometimes outside the wall also. But somewhere in your house, there will be this thing which is going to distribute the electricity further into different sockets in your house. So that will go into different elements, but we know all of them are connected in parallel. So if it is like, if this is like the first bulb that we have, then you have the second bulb, then the third, all of them are connected in parallel like this. And this is going to go into the live wire. And this is going to go into the neutral wire. That is how this goes. Again, imagine like roughly we can draw over here right now. This is the distribution board. What is the thing that I'm missing till now in this?
So earth wire.
Yeah, the earth wire. The sockets, they do not have just two holes, live and neutral. There's an earth hole also. So earthing wire comes from here and all of them are connected. This is represented by green. This is the earth wire. All of them go into the earth. You can draw it like this also. So this is the circuit that we're going to draw for the domestic circuit. Anybody, any questions in this? Yes, Shinjini, you had asked some question, right? About fuse.
Yes.
So why are you asking particularly for 5 ampere and 15 ampere?
So what are the two ratings for which we can use the fuse, right?
Depends actually upon the electrical circuit. Let me tell you. Oh, that is why. Okay. Like depends. For example, there's a heater, the rating of which its rating is given as hmm, 50 watt, 8 volts. Then in that case, which fuse will you use? So we are saying we have given you two options. You have options of using any of these two only, 5 ampere and 15 ampere. Which one of these will you use? No, Avida, no around. Yeah, Avida, right. Gas engineering, correct. Yeah, Jasim. But if you have only one of these two options, which one will you go for? Arum, correct. No, Jasim, wrong. No, Ashita. Guys, see the common mistake that you're making over here. What is given? Power is given as 50 watts and voltage is given as 8 volts. So what can you find from this? You can find the safe current through it. Like how much current safely will pass through it. So how would you find current if power and voltage is given? Power by voltage, which is 50 by 8, which is no Ritik, which is 6.25,
2.5 something.
6.25 amperes. That means you can safely pass 6.25. What would happen if you pass current lesser than 6.25? Nothing. It will glow but with lesser brightness or like will lesser heat up. But if you give current more than 6.25, what will happen?
Circuit will
It will malfunction. So imagine if I use 5 ampere fuse, will this heater malfunction or will it not for any particular value of current? Will it malfunction? Yes or no for any value of current? Yeah, it will not malfunction. Will not malfunction. Why? Because circuit breaks as soon as 5 ampere passes. So the fuse will break, the heater will be fine. But if you start using the 15 ampere fuse, the problem will be if, for example, the current becomes 8 ampere. If current becomes by chance due to some variation in the electricity supply, current becomes 8 amperes. What would happen in that case? Fuse will not break. Fuse does not break. And 8 ampere current passes through heater, which is not wanted, but it just happens. 8 ampere passes through heater and it malfunctions. So that is why we're going to use the 5 ampere fuse. That is that is going to ensure that the heater is safe. Okay, guys, so that will be our last class. We have revised the entire syllabus and important questions of all the 4 chapters. Yes, engineering.
So what if the current was like 9.9 ampere something? So should we use 5 or 15?
Sorry, if the current, I mean, you are trying to say if the fuse was 9 ampere.
9.9 ampere or something like that, like very close to 10.
Okay, like close to both of them.
Yeah.
I think this is not the appropriate example. Let me give you the example. Guys, think about this. If the maximum current that can safely pass is 8 ampere, let's say maximum current that can safely pass is 8 ampere, and you have fuse of two options. One is 5 ampere, other is 7 ampere. Which one will you use? Correct, Asim. Yes, Abhita. Yeah, I'm right. Guys, see, in which, Shanjini, tell me, in which of the two cases will the heater malfunction? Which fuse cannot ensure?
7 it will malfunction.
No, it will not malfunction in any of them. Does not malfunction in any. Because imagine, if the current exceeds 5 ampere, the fuse will break and the heater will be safe. It will never be able to reach it. And if the current exceeds 7, this fuse will also break. Will never allow the current to increase to 8 and heater will never be damaged, right? But then which of them should be used? Which one will be preferred? We would prefer 7 ampere. The reason for that is because the first fuse is going to break very quickly. 5 ampere itself. If we want, we anyways, like we do not want it to exceed 8 ampere, but we still want it to heat up to 8. So it's better, at least we can reach up to 7 using this. The first one is going to break even before that. You get it?
Yes.
AC and DC graphs, Ritik. DC is basically when the direction of current is not changing. So current or voltage as a function of time is going to remain in the same direction, like positive throughout. It's not going to go negative ever. Whereas in AC, the direction is going to alternatively change. Like that is where the name alternating current comes from. In AC, it's going to be like positive, then negative, then positive, then negative, and so on. Okay.
So can you check the question I sent?
Yeah, you sent on WhatsApp?
Yes, sir.
Okay. Okay, let me just put it over here. Yeah, Ram. Yeah, which question have you doubt in?
So like the B one.
You will plot this for each other. What value should each slope have? Okay. You're going to draw V versus I graph. V versus I. So V will be in y-axis, I will be in the x-axis. For each what? Of the 4 circuits. Okay. Okay, fine. So if I draw for R1 first, R1 is like when the voltage is 0.01, current is 0.01. So it's like 0.01, 0.01. Then 0.02, 0.02, right? So the graph is going to be like this. Got it?
Yes, sir.
And slope's formula is y2 minus y1 upon x2 minus x1. So it's this y2, 0.02 minus this y1, 0.01 divided by this x2, 0.02 minus this x1, 0.01. So slope comes out to be 1. Achha, you wrote current instead of V. Okay, Ritik, you're saying you wrote I over here and V over here. Then, Achha, for AC, of course that is wrong then. That's the wrong answer. Achha, okay. You are saying the graph, okay, instead of voltage. It is the same thing. Sorry, it's the same thing. Here you can draw current also, write current also. Current and voltage both say the same. Is this fine, Aram? This is what you wanted to know?
Yes, sir. So, and like we don't have to draw the graphs for like the first combination and the second combination,
No,
right?
actually, you have to draw for each of the 4 circuits. Is that
So,
fine?
the circuits containing the individual resistors and like the resistors with equal resistance in both cases.
Yeah, all 4.
Okay, sir.
Okay. Fine then, guys. Anything else? Anybody?
So what is the answer for the first one? Which combination represents series and parallel combination?
This third one you mean? Third one you're asking, na, Shinjini?
The first one.
First one.
Achha, which? Okay. See, one resistance is 1, other is 2. So in which one of them the resistance increases? In which one are you going to add them? In series. And if you notice, this is 1 upon R1 plus 1 upon R2, 0.66. So this is parallel. From the value of resistance, you will get this. Correct? This is 1 plus 2. This is 1 by 1 plus 1 by 2 is reciprocal.
Sir, and bulbs will burn brighter than series, right? Because
You think bulbs in parallel series will burn brighter? In parallel. Imagine. So guys, the last question is, in which of the combinations will the bulb glow brighter? Imagine both have resistance R1, R2. So when they are, like, imagine like this. R1, R2 connected to battery of voltage V. And then R1 plus R2. Same battery of voltage V. So don't you think in this case, voltage divides over them? Voltage divides. But in this case, same voltage, undivided voltage. So basically, this will be brighter. You're getting the reason? In the first one, both will receive V volt. But in the second one, that voltage will divide over the 2 remaining. So this is going to be the dimmer one in series.
so, but in the first one, current will be divided, right? So if current is less than the
But current is not fixed. It's right, but current is not fixed. It's like if 2 ampere is coming from here. In this case, 3 ampere will come here or 3 ampere will come here, but 6 ampere will be coming. So it's not like current is fixed. 2 ampere here, this 2 ampere splits over the 2. That is not the condition. But in voltage, it is the condition. Fixed voltage is there. This voltage will divide, but here the same voltage will go. You get this?
Yes,
Or you want me to repeat this?
I got it.
Okay. Fine. Okay, guys, fine then. We're going to have one more session, one more DRS. Like for you guys, if you guys have any doubts over the next week, we can clarify over there. No problem at all. Okay. Bye-bye then, guys. All the best. Prepare well.
Thank you, sir.
Thank you,
Okay,
sir.
bye-bye.
Thank you, sir.